Hey guys, Kevin Stumpf here with URETEK USA, and I want to go over a project today that we did in Missouri for the Missouri Department of Transportation. This is a project abstract. It's got a lot of detail, a lot of data in there. I'm going to try to keep it real simple and go pretty fast, but I do encourage you to download it. Click the link and download it. This project profile was put together by Rick Boudreau of Boudreau Engineering in Atlanta, John Donahue, who's an engineer with the Missouri Department of Transportation, and Dr. Randy Brown, who is an engineer with URETEK USA. Okay, so here's the situation. Missouri Department of Transportation did a cut and was installing new asphalt, okay? They quickly saw rutting and cracking, and the compactor equipment was pumping as it was driving by. And they're like, wait, we got a bigger problem here. We better stop before we move on. So they called us in, and they wanted to see if our URETEK Deep Injection process could help fix the base issues so they didn't have to re-excavate, bring in fill, and they were under some tight timelines. So we came in, and the first thing we did was dynamic cone penetrometer testing. Okay, I encourage you to look at my blog about that and learn a little bit more about that. Basically, it gives us an indication of the strength of the soil at different depths. Okay, so this is the results of the 5 different DCP tests. You can see this is near the surface. This is about 4 feet. It's getting worse, and then gets better. So up around 12 feet, it looks pretty good. 4 to 7 feet, not great. So what we did is we inserted pipes to 3 and 4 feet, depending on what the results of the tests were. And we injected our polymer until we saw the asphalt move just a little bit on our laser levels. So we call that a bump. Now, when we see the ground bump, we know that further injections will cause it to come up more. So we stop and consider that area stabilized at that point. Now, moving forward, I'm going to skip these graphs here. They're just indicating that when our material is injected into like aggregates, sand, and things like that, it actually creates a stronger material. It bonds together and is stronger overall. I'm not going to go over that, but I do want to talk about some of the results of some other testing we did during that. Okay, so the Missouri Department of Transportation brought out their falling weight deflectometer machine, and I'll show you a picture of one. This isn't theirs, but this is just a sample picture of a FWD machine. Basically, this machine hits the pavement and checks for deflection, and it gives you a reading of how strong your subgrade is based on that. Okay, so right here, you can see that the average initial hit showed 8,870 psi, and we improved it to nearly 13,000 psi. So that's nearly a 40% improvement in subgrade stiffness just by injecting polymers into the ground without excavation. MoDOT then installed a geogrid and 3 3/4 inch of hot mix asphalt, and that improved it to 14,750 psi, or a 70% overall improvement. Came back 5 years later and tested it again, and it averaged 23,000 psi. So it got better over time, basically. So these are some graphs showing these results. To summarize this project, we came in and were able to get an immediate response, get immediate improvement in the subgrade to where they could finish their construction project, get the public traveling on the road again, and then over time, the pore pressure dissipation is kind of a slow process. So removing the water and air from those soils down there takes some time, and over 5 years, it actually improved the strength of the subgrade. So it's kind of the gift that keeps on giving. We come in, fix it immediately, and over time it continues to get better. So guys, trying to be quick. It's tough with this one. There's a lot of data here. Download it, read it, review it. If you have any questions, feel free to give me a call. We'd love to help you out with your subgrade issues. So thanks. We'll see you.